looks like it's settled down a bit. So let's start, because otherwise we'll run late. So there might be a few more joining, but that's okay as we get into it. So good morning, evening, afternoon, wherever you are. Welcome to the midterm webinar for the UAS challenge. So I'm Paul Lloyd. I'm the chair of the event. So what you're going to hear today is a chance to run through some key aspects that you need to know at this stage of the competition. As you can probably tell, when I'm not doing the competition, I'm in the Air Force, but that's not. I'm not going to be doing that today. So, but this is very much your session. So please listen in to what the various presenters talk about, covering some practicalities from the IMechE team around visas, etc., all the way through the explain and how we run the competition, etc. So, please listen in. This is sort of critical information for you and your teams as you run through the competition. But this is your session, so it's really important that if you've got any clarifications or concerns or issues, that you raise them, and we've allowed some time for Q&A at the end. What we'll also be able to do, obviously, is if we don't get to your question or you have a question subsequently, we're more than happy to answer those as we go through. I suspect in a lot of cases we will say that's already in the rules. They are very comprehensive. We spent 10 years developing them. So quite often we find that actually, we can point you to the right point of the rules again, and that can clarify. But clarification is always useful. So I will start handing over to the team to go through the various presentations. Please listen in. I guess the answer, Alice, is to put your questions in the sidebar. I think that's the way you'll probably do it, and we'll get to them at an appropriate point. So I'll hand over now. Alice, you're going to start now, is it?
Yes, thank you very much, Paul. I will take you through the agenda for today's webinar. So I'll be taking you through competition preparation, remind you about your visa applications, transportation and shipping, and liability insurance, with a few other admin reminders as well. And then after that, you'll be hearing from Will Cave on explain submission and the timeline. And then after Will's presentation, Lambert will talk to you about concept papers, design and development specification requirements. And Rod will take you through the readiness review and scrutineering. And then we will have a technical update by Spirit, followed by the Q&A session. Next slide, please. Okay, so I'm going to take you through the preparation you need to be doing in order to get yourselves and your UASs to the fly-off. You will have seen these slides before, but we would like to remind you of what you need to do, especially if you are coming from outside the UK. Next slide. If you're attending from outside the UK, it is your responsibility to check on your visa requirements to enter the UK. So on this slide, we have provided the links you need in order to check if you need a visa to come to the UK and the visa processing times for your country. You will need to apply for a standard visitor visa, and you can apply online. Even if you do not need a visa, you must still meet the standard visitor eligibility requirements to enter the UK. We recommend that you apply for your visas now, because you have just over 3 months or 14 weeks until the fly-off in Buckminster. A PDF of this information is on the website, so please have a look as part of your preparation. The IMechE will provide you with a letter of support inviting you to the competition for the fly-off dates. To request a letter, please send us an email to the uaschallenge@imeche.org inbox and check the website for all your requirements. Next slide. Again, for overseas teams, we recommend that you make contact with RJJ Freight Limited, our customs shipping agent, for advice on shipping your UAS. If you give them the specifications and contents of your UAS, they will advise you on the best way of bringing your device into the UK. As well as your local Chamber of Commerce, RJJ can also advise you on ATA carnets so that your goods will not have to pay VAT or duty on deposit. We will be emailing the team leads with RJJ's contact email address. Next slide, please. Liability insurance will apply to every team member, and there will be an option for teams to join the BMFA on a temporary basis to cover liabilities arising from your participation in the competition. The cost is £8 per person, and this provides cover for 1 month, and we recommend that you bring proof of your temporary membership to the fly-off event in July. There will be an online payment system available to you, and a link will be coming soon and communicated to the team leads. Next slide, please. So in summary, please check your visa requirements and contact the IMechE for a letter of support. Contact RJJ Freight Limited on how best to transport your UAS to the UK. For liability insurance, an online payment link will be coming soon. And lastly, I have just a few reminders. So if you haven't already, please order your payload from Jonathan Cook at Dropbox. Send us your team's contact information. Campsite bookings are open with details on the website. The cost is £360 per pitch for 10 people. And please note, we will be asking you for some marketing information, such as your team logo. Please look out for the next email to team leads, which will contain all of this information. Next slide, please. So here's the team list for the year. We have a total of 38 teams coming from all over the world, and I'm sure you'll make our 10th anniversary year one to remember. And we look forward to seeing you in July. Thanks, Lambert, over to you.
Yes, hello everybody, and welcome. Just a brief reminder about the competition timeline. I mean, this is where we would envisage that you should be today. So you've done your concept. We hope by now you've completed your design and you're well into yours. Well, the simulation part of it, you'll be delivering your X-plane simulations tomorrow, and you should be into doing some subsystem testing at this stage and probably starting manufacture. You'll then move on to doing full system testing, we'd hope, and eventually on to flight test. The Spirit team will give you some very useful advice about testing a little later on in this webinar. Right, I'll now hand on to Will, who will go through the X-plane submission.
Good morning, good afternoon, or however it applies. Next slide, please. So I'll start off with X-plane submission. Sorry, I'm looking at my screen because I've got the dates here. X-plane submission deadline is tomorrow. So please do your best to get us your models before the end of tomorrow, and then we can start going through and looking at them and scoring them. So to what we've got on the slides in front of us, as a summary, briefed this already, but this year the X-plane model is quite a significant number of points, 150. That does include the model and the pilot handbook. Please, when you are sending us your X-plane submission, that you do include all of the files necessary for your model. A good way of testing whether you've done that successfully is to have a fresh install of X-plane on computer and then load up what you are sending to us in that model, and if it doesn't work, then you've got something missing in your file structure. So things like airfoils can either be located within the aircraft's file structure, or X-Plane has a global airfoils file structure. So if you've modified your global airfoils and you're using one of those, when you send it to us, we won't have that because our global will be different to yours. So please do a quick test before you send us your models that you have included everything that you want us to see. And stuff like object files as well. You know, if you want it to look particularly pretty, if we've not got those object files and texture files, then to us it'll just be a grey blob. Next slide, please. Yeah, so Christina and I will be flying all of the models. We have got a lot of models, hopefully, to fly. And we won't have a lot of time to try and bug fix your models if we can't get them to fly immediately. So that's another reason to please go through and not only check that they load, but check that they fly as intended. Key point, second bullet there. If you have a configuration that is difficult to simulate in X-Plane, please include the differences between what you're providing in X-Plane and what you anticipate the fly-off vehicle will be, and then we'll have to use some judgment on how we score those. X-Plane 11 only. So the latest version of X-Plane is X-Plane 12, but we've not got licensing for 12, so only use X-Plane 11, please. If you send us a file from X-Plane 12, it won't open. If you happen to have X-Plane 10, then it will open in 11, but we can't guarantee that it will behave in 11 as it was doing in 10. So please, X-Plane 11 only. Next slide, please. Breakdown of the scoring. So the first two bits, the pilot handbook and the plane maker check. So pilot handbook, we're using a mouse or a joystick. Joystick and rudders as appropriate. Sorry, that was a question in the chat for those of you who wonder what's going on. The question was, will we be flying with a mouse or a joystick? Flying with a joystick, yeah. Plane maker check, yep. So this is to check that the model that we've received matches with the model that you have designed and has been provided in the previous submissions for your concepts, just to make sure we're not comparing apples and oranges. And then we'll go through and we'll do the fly-off mission. And like I said, we'll go through it twice. Next slide, please. Right, okay, so any other questions, either jot them down or hold them to the end and we'll cover them then. But otherwise, that is me. Thank you very much.
Well, hello again, back again. So I'm now going to talk a bit about what the judges do and your next deliverables. So if we can move to the next slide, please, Fiona. So just a reminder, the judges are here to award scores clearly to lead up to the prizes at the end of the competition. But we're also here, to us, really very importantly, is to provide you with some constructive criticism and advice. And so please take heed of the advice you're given, not only in the webinar today, but in written responses that we send to you. And in return, I mean, what we're hoping that you're going to provide us with is an interesting UAS design, and particularly one that meets all the requirements of the rules and not just the requirements that you fancy, as it were, but all the requirements of the rules. We do expect you also to follow precisely what we ask you to do in delivery of documents, etc. That's quite important, and a big learning point going forward is when you get into industry, it's really important to respond exactly to customer requests. They tend to not be very keen on you providing what you would like to write rather than what they have asked you to write. And please also submit your deliverables on time. And what we're hoping to see at the end of the day is a lot of fun at Buckminster, with you all arriving with a fully tested and compliant UAS. And again, the Spirit team at the end, in fact, 2 of our judges from Spirit will be giving you some very useful advice on testing at the end of this webinar. And please make sure you're reading the right set of rules. We've in the past had teams that have been reading the rules of the year before, which isn't terribly helpful. And as I say, make use of the advice given to you. And as Paul has said at the beginning, if in any doubt or don't understand anything or want clarification, please ask. We're more than happy to try and help you, because it's in all our interests for this to work out successfully at the end. So the next slide, please, Fiona. So just a quick reminder of some of the key points of the rules. Now, this doesn't absolve you of all the other requirements. You've got to meet them all, but I just picked out some of the big points. One is that this year it's an urban canyonade mission that we're simulating. So that involves some quite tight turns, and you should be aware of that. Again, your maximum takeoff mass must be 10 kilograms or under, and that includes your payload. The scrutineers will weigh your aircraft, including its payload, and if it's more than 10 kilograms, you will not be allowed to fly it. You mustn't make any modifications to the payload box. So if you need something to attach it to the aircraft, this must be, whatever it is, must be removable without any tools and without doing any damage to the box. And if you need to stuff something in the box to stop the sand moving around, again, it mustn't be any permanent fixture at all. And remember that whatever you put in there will contribute to the 10 kilogram maximum takeoff mass, but won't contribute to the points you score for delivery of your payload, because it's only the sand that contributes to the payload score. You're not allowed to hand launch your aircraft. You can take it off horizontally or vertically, or catapult it off, but no hand launching. The commercial off-the-shelf components, we put a limit of 1,300 UK pounds this year. We do appreciate that, particularly for overseas teams with exchange rates and transportation costs and things like that, that may be tight. And so, although it's a recommended limit, if you do have to go up above that, you must give us some justification for that. But remember, aid agencies don't have very deep pockets of money, and so we're trying to get you to build a cost-effective UAS here for doing this mission. Your takeoff has to be within a 10 meter by 10 meter box, but your landing has a bit more leeway with a 10 by 20 meter box. Remember, you must, when you're taking your aircraft out of the storage box, you must be able to assemble it without tools, except you can use spanners to fit the propellers, but assembly without tools from the storage box. You must write show your centre of gravity position on aircraft drawings and on the vehicle itself. And this is trying to help you to encourage to think hard about centre of gravity. Now, this year also, we've introduced a requirement that the flight safety officer will first do a manual flight with your aircraft before you go and do your autonomous flight. And this is so that we can see that you've designed this aircraft properly. You're not relying on the autopilot to correct a poorly designed aircraft. So it must fly nicely, and say you will get points for the flying qualities that the flight safety officer can see. You'll need to bring a portfolio of your documents, printed copy of your documents, to Buckminster. When flying at Buckminster, you must obey or be compliant with UK drone and communications regulations. And clearly, when you're flying in your own area, you must be compliant with whatever your own area requires. And just a couple of safety points at the end. You must have an externally removable link that isolates your motors. And clearly this has got to be in a position away from the propellers so you can safely pull that out if necessary. And you also must, when flying at Buckminster, be compliant with our flight termination system requirements that are specifically designed for operation at Buckminster. So the next one, please. So I briefly mentioned before the deliverable, the timeline, but just in terms of deliverables, you've delivered your concept papers, thank you, and a very good set of concept papers, and you should have had the feedback on those, and I hope you've taken note of that feedback. You will by now, I hope, have done your own PDRs and CDRs, and you'll bring evidence of that along to Buckminster. As well as said, your explain submission is due tomorrow, and then 3 weeks after that, we're waiting to see your design and development specification, and I'll talk a little bit about that in a moment. And then we expect you to do your own flight readiness review, and I will mention that in a moment, before you start your flight testing. But the next deliverable will be your FRR form, the IMechE FRR form that Rod will explain to you in more detail shortly. And then obviously turning up to the demonstration event. So the next slide, please. So these are the deliverable dates. The explain simulation tomorrow, design and development specification on the 12th of April, and then the flight readiness review form on the 14th of June. And please follow exactly the format we ask, because if you try and do your own thing, we may not look at them. Next one, please. So just on design reviews, as I said, this is what industry uses to make sure that what you've been developing actually meets the customer requirements. And so, as I say, we would have expected you already to have done your PDR and CDR that we talked about at the last webinar. The flight readiness review is in industry. Before we fly for the first time, the team would go through a flight readiness review, and we'd expect you to do exactly that, to make sure you're ready to fly and you don't waste all the work that you've done there by crashing your aircraft on its first flight. And so in the flight readiness review, we'd expect you to make sure that you are fully compliant with the rules. You have done as much ground testing as you possibly can to satisfy yourselves that everything has been covered and that you've got the very, very best chance of your first flight being successful. You'd also need to make sure that from a legal point of view that you've got all the necessary licenses in the UK, you will need your flyer ID and your operator ID in place, and wherever else you're flying, that you have met the legal requirements for doing a flight, and that the test location again is a legal location. And we'd expect you to go through a full risk assessment for the location that you're going to be doing your flying, so it's safe for you and anybody else. And then, as was mentioned, you must fill in the specific form, which has details of insurance, etc., must be loaded up on the 14th of June to Mashoom. And the next slide, please. So the next deliverable to the judges is the design and development specification, and that's about specifically describing the detailed design of your UAS. Now, please follow exactly the format that we've asked you to do in Annex D3 of the rules. Now, it's a relatively small document, 22 pages maximum, plus the cover page. On the cover page, please make sure, follow exactly what we've asked you to do on the cover page, but make sure you've got a decent graphical image of your aircraft. Then in the summary, I'm not going to go through all of these in detail, but in the summary, it's just a brief summary description of your vehicle. But please, if you've made any significant changes since your concept paper, describe those as well. Then going through the other bits, project management, where have you got to on your program? Requirements review is to make sure you have understood and are implementing all the requirements. Your design description is the bulk of it. We'd like to see reasons why you've made certain design decisions, as well as describing those designs, but why you've made those decisions. And please make sure you include a dimensioned and labeled 3-view drawing of your aircraft as well. On the safety section, we want to be satisfied that you've taken safety seriously. So again, write what we've asked you to do, but do it in a way that we can be certain that you have thought hard about safety requirements. Manufacturing support, again, don't forget to tell us about your storage box and any special equipment you've got. Testing, how you've laid out your ground and flight tests. And again, more clues will help you with the ground testing later. And then on the costs, we want to understand the full cost of your UAS, but split out the detail of your commercial off-the-shelf systems. But remember, each section, please stick to the page count that you're given. If you go over it, we won't read the bits that are over it. Next one, please. The scoring, again, is laid out in the rules, as well as explain. The X-plane model is a significant part of the scoring this time. And then, of course, the flight demonstration has the bulk of the scoring. The 100 points for pre-mission are for your storage box and your assembly of the aircraft, and for the manual flying that the flight safety officer will do, which accounts to, again, a significant 100 points worth. And the next one, please. So the mission scoring, again, look at that in the rules. You can see where you score points, and so it will help you plan your missions and what you're going to concentrate on. Remember, the total mission time is 15 minutes, and assuming time permits, we hope each of you will have 3 attempts at scoring on the mission, and we will take the highest score of those three attempts will be the score that we will use at the end. And on to the next one, please. Right, so it's now time to hand over to Rod, who will explain to you about the readiness review.
Good morning. Yes, I'm Rod Williams. I'm the UAS Challenge Chief Scrutineer, and I'm going to run through the flight readiness review, particularly the deliverables. So what is the FRR? It's a formal requirement to provide the evidence that your UAS is safe and ready to fly. We will expect your submissions on the 14th of June, as Lambert has just said, so that's a clear 2 weeks before the fly-off competition itself. But what does that include? Importantly, we need those 5 elements: a statement of changes that you've made, so that when we see your UAS at the event, we know if there's anything that you've evolved and made modification to your platform. Certainly, again, as Lambert said, any corrective actions that you've raised following the design reviews that you've had, and the feedback to see what you have done on the advice from the judges. A declaration from a chartered engineer that they are happy with what you have produced. And importantly, you need to have some pre-flight procedural checklists, particularly the leading particulars for your platform, and a bit of a statement in and around the team pilot's experience. This is done on what we call the Form 701. Could you click on, please? As you can see here, you can see the form, and at the top on the left, you've got those earlier requirements we've stated, but it also has the ability to put in your details over your insurance requirements, and your CAA details, your operator and flyer ID. Importantly, we no longer, we used to ask for a short flight test video to show the UAS in all stages of flight, but we don't require that anymore. But I would suggest that it's something worthwhile doing, having a short, I don't know, 3-4 minute video that you can display when you're in the pit lanes and show to us, the judges and the scrutineers, what you've done, and how your flight test schedule has gone. With this Form 701, it's quite detailed, several pages, and as you can see here, what we will do is put a PDF exemplar on the system for you, so you can see what you have to complete. The areas in blue are those that are important for you. There will be a blank form there that you can type into, but what we want you to do is not just leave what's written in the example set there. We need your details put in there. Could you click again, please? Additionally, we want to see quite a lot of technical detail on there, and on the second page of the Form 701 is a little table where you can insert cropped images to show those elements of the UAS that we would like to see. Again, can you crop them and keep them to size in the form, please? And then finally, on the back page, the third page, there's some additional advice for you at the top, and some details. Could you click again, please? Highlighted here, of things that you might want to consider preparing, so that when we're looking at your platform and having a discussion with you in the pit lanes, we can pick up on those things. What you've done around the flight test, as I say, useful to have a video for that. How you're organised and how you have changed, done modifications, and updated your platform, and those procedural checklists. I think there's a little arrow appears if you click again there. And as I say, particularly having the leading particulars, that will be very useful. So details of weight, stall speeds, takeoff speeds, operating speeds, and those leading particular information will be very useful. Next one, yes. Finally, some top tips. As Lambert has said, really you should be well into your planning and your schedule, and hopefully be actually building your aircraft at the moment. We would request you pay particular attention to documentation. It is there actually to help you. It's also a necessary part of the aviation world that we have an audit trail in order to be able to qualify and certify aircraft systems. We have included on the UAS Challenge website a couple of PowerPoints, if you could click, which go through some good practice guidance in how you should build things and what sort of detail you should be bringing with you. So you should be able to find those on the website itself. Good luck in your final preparations, and I and my scrutineering team look forward to seeing you in July.
Hi everyone, Stephen McLaughlin here from Spirit Aerosystems in Belfast. Stephen Higgerty and I are going to chat you through a bit now on test and manufacturing or assembly of your UAS. Next slide, please. Firstly, we'll just give you a bit of an overview of who we are before starting to talk to you. So do you want to go first, Stephen?
Yes, I am Stephen Higgerty, so I'm the bearded Irish Stephen on the left. I graduated from Queen's with a degree in aerospace engineering in 2012 and have worked for Shorts ever since. So you may know us differently as Bombardier Aerospace or more recently Spirit, but under all that, the company here in Belfast is Short Brothers and has been for over 100 years now. So 11 years here, 8 of those I spent doing quite a lot of work on ground flight test article design. So I've a quite comprehensive background in testing. Currently working in our European Space and Defence branch, and I've been a judge in the IMechE Challenge since 2017.
Okay, thanks, Stephen. And myself also graduated from Queen's University here in Belfast, just a year before Stephen Higgerty. I graduated with mechanical and manufacturing engineering degree. I then joined Bombardier as it was then, but Shorts, as Stephen's already explained, been in the same department in materials and processes engineering now since 2011. Worked my way up through the department and now managing the chemical and environmental technology team for the past 3 years. I've been actively involved in volunteering with the IMechE. I started my IMechE volunteering journey as a UAS challenge judge in 2017, and somehow got my arm twisted by Paul, who's also on the call here, to start to join the Aerospace Division Board and represent the Aerospace Division Board in the IMechE's Young Members Committee. And since then, I've taken up the role as the chair of the Aerospace Division Young Members Committee, which I started last year. Over the next couple of slides, we're going to talk a lot about test and then go into a bit about manufacturing. As you can see from Stephen's career to date, he has been very heavily involved in flight test article design and things, so he will do most of the talking over the next 5 to 10 minutes, but I'll butt in and add where I think it's appropriate. Okay, next slide.
Is there text missing off that for everybody else? Okay, yeah, if you just fill out the slide, it should all come through at once. Thank you. There should be 2 more slides to it, I think. That's it. Thank you very much. So going back kind of to what Lambert was saying about the timescales and kind of where you should be along the road anyway, some of this might be a little redundant. I'm hoping it's a little redundant because if everyone's kind of doing this right as such, you should be into some of this testing and assembly activity anyway. Some of it might also be a little redundant from the point of view of we'll talk about how we tackle things in industry, which may or may not be applicable to your aircraft, but it still should be of some interest, and hopefully you'll see the through line from kind of what you're doing in a very, very compressed aircraft development type cycle into what actually we do in industry, and the two things aren't all that far removed, really. So first off, why do we test in the first place? So there's a whole list there. Generating knockdown factors and design guidelines. So particularly if we're working with new materials, when we came to do the wing of the C series, the A220 as it is now, it was the first carbon fiber primary structure we'd ever done. And you can do all the analysis you like on paper, but unless you actually physically go and test something, you can't be 100% sure that what you've done in your analysis stands. So that kind of takes you on to the second point there, verifying analysis methodology. So not just structural, good aerodynamics there, performance, factors of safety, all of the calculations, computer generated type work you're going to do, you need some physical testing to back that up. As you work through an aircraft program or a series of aircraft programs, some of that testing will carry forward, and you can maybe reduce testing in future programs off the back of things you've done previously. But for a one-off aircraft, you're really going to want to do something that shows yourselves, us as the judges in industry, the regulatory authorities, that your calculations are good, effectively. The next piece there is that's not critical for a one-off aircraft or a low-life aircraft as you're doing here, but for serial production, we're talking about verifying statistical methodology, manufacturing variability. So, for example, the picture in the bottom right-hand side there is the Global 7000 horizontal stabilizer. That stabilizer that you see in the picture there had a whole load of fasteners missing. It had saw cuts put into it. It had parts missing. It was deliberately designed to be in worst shape that we could ever possibly put out of the factory. And the reason for that was to show that if it passed the test in that state, the production standard one that's, ticked all the boxes from a quality point of view would be more than robust enough for the flight cases. Now, I say that kind of applies to serial production, where over the lifetime of an aircraft, you may have various issues in service or in the factory, and you're trying to test that you can capture those sort of variations that you mightn't predict on day one. The next bullet point then, there's a very important one, demonstrating compliance. So for us in industry, we're looking at the CAA, the FAA, EASA, all the regulatory authorities. So at the end of the day, they're the group that signs off that our aircraft is good and good to sell and ferry the paying public around the world. In your case, you're demonstrating compliance to the competition rules, but it's the same sort of situation. You've got a rule set there. It's not up to you to say the aircraft's safe or compliant. That's up to us as judges and scrutineers and the various other IMechE teams that are involved in this. So you need to show us some evidence that what you've created and what you've tested is fit for purpose, effectively. And the overall goal, as I say at the bottom there, is to produce a safe aircraft, also robust, also lightweight. If you test something and it turns out to be way stronger than you predicted, that's not necessarily a good result. Chances is your aircraft's very over-designed and very heavy. But the ultimate goal is safety. We want to show that whatever you're going to put in the air is safe for flight. So, I don't know if you've anything you want to add, Stephen?
No, nothing to add. You covered that all well. Good one.
Cheers. As you go on to the next slide, that's kind of why we test. How we test then. So this diagram you see at the top of the page is called the pyramid of testing. And this is a standard tool used across industry. It's actually defined in one of the mill handbooks. So in any aerospace company you go into, you'll probably see this approach being used. And what it's really showing is the types of tests that you would do over the life cycle of an aircraft development, but also the numbers of tests. So at the bottom of the pyramid at level 0 and level 1, you're doing an awful lot of testing of very small components, working your way up in complexity of those components, but reducing the number of tests. So if you look at the wee diagrams there on the right hand side, that's the first one. There's kind of a level 2 element test. So that's just two pieces of carbon fiber bolted together, and that would have been tested in tension. Would have pulled that specimen apart to see kind of what level of force it took to break it and how it broke. We would have done hundreds of those, slightly different configurations. We would have done shear and compression, various variations on that theme, but there were hundreds upon hundreds of those tests done. We then moved up in complexity to what we call a level 3 subcomponent. So that's starting to look like something an aircraft might be made from, but it's not. It's not actually lifted straight from the aircraft design. It's a flat panel as opposed to curved. But it does, it's got stringers, it's got ribs, it's starting to look a bit like an aircraft, and we still would have done in the region of 100 of those. And then moving up in this example here to the winglet test for the A220, there was 2 of those done, a fatigue one and a static test one. So the message here is that you don't necessarily need to wait until you've got your whole aircraft to go and start testing it. There are things you can learn from doing very basic tests. Things like validating your FEM or stress analysis methodology, whether it's hand calcs or finite element. Design something very simple and run the calcs on it and run a test on it. And very early, before you've actually gone and developed any real aircraft structure, you'll know where your calculation's right or if you made any simple errors that are going to carry through into the all-up test. So it's worthwhile starting the testing early and starting in very, very simple components. The test pyramid applies to systems as well. A lot of the pictures there you see are structures, but we would expect to see systems testings approached in the same way. You're starting from element levels into subcomponents into all-up systems. Again, the key message in this slide, if you look at the bottom there, what percentage of ground testing do you need to complete before first flight? So we in industry would have a milestone, if you like, called safety of flight, or it's maybe called different things across different companies, but the principle stands. We will have a minimum criteria to meet before we're allowed to put an aircraft in the air. Now in this competition, it is yourselves who decide when you're going to go first flight. You know, we're looking for evidence to allow you safety of flight at the competition, but you'll have to do a level of flight testing before that. And the key thing is it's easy in this competition. It's very exciting because you're not just designing an aircraft, you're actually going to building it and flying it, and it's easy to get swept up in that excitement. But you kind of need to remove yourselves from that and understand and set out your own criteria for what ticks in the boxes effectively do you want and do you need before you would say I'm comfortable putting this aircraft in the air. And if you haven't hit those criteria, you don't fly. You go back and you fix something before you fly the aircraft. Anything you want to add there, Stephen?
It's probably worth just pointing out in this slide as well that all of this testing and the pyramid of testing requires a lot of interaction between various different engineering departments. So it's like likes of a stress engineering department might define the requirements or the test plan for a lot of the testing, pass that on to likes of Stephen in his previous role as a design engineer on test. To do all the design of the test articles that he's got on, like for example, the test articles got on screen there, the three examples, and then that would come to kind of my workshop to kind of do a lot of the manufacturing and assembly of these components, and then go to the test lab that we have in my department as well to carry out the testing, report on the testing back to the stress engineering department. So there's a wide engineering team that's involved in this whole pyramid of testing, and I think it's just pointing out that as well, Stephen, that it's not just one small group of people working on this.
Yes, yeah, it's an enormous effort. Yeah, absolutely. All right, next. So again, go right back to the start and where we are, and Lambert showed the wee schedule of kind of where he expects the team to be. Hopefully you're already doing this, but this is just a little message to talk about current engineering. So if you were to map out, you know, without any sort of experience or background, if you were to map out an aircraft development program, you might do all your design work up front, then make something, then test it. But the real world, unfortunately, doesn't work like that. Largely for timescale reasons, you know, aircraft development cycles these days are starting to run into decades anyway. We just can't afford to do all the testing at the back end. The other thing, of course, is risk. If you do all that work up front and then test it and find you've got something wrong somewhere very early on, you could be back to blank page and starting all over again. So you need to design your test program to run in parallel with the aircraft development. And that's kind of where the pyramid of testing comes in too. Start with the lower level stuff. You don't need to wait till you've got a full wing in your hands to go and test. Start testing subcomponents, testing smaller things. Map out that test plan. As Stephen says, it's a massive multidisciplinary exercise. So if you need bespoke test articles designed, so you know, again, take the wing for example, you're going to build a pair of wings. If it's a fixed wing aircraft you're developing, you have a pair of wings for the flight aircraft. Do you need a third one to test, or are you going to do your tests on a flying wing? But what's the risk of that? If you need a third one, you need to be telling your manufacturing team, I need you to make me 3 of these, not 2. You need to maybe tell your design team, I need a third wing, but it needs to be slightly different because I need to grip this at one end on a bench so that I can do a bench test with it. So it's making sure that all that communication through the whole team and all the disciplines is there, and that they understand the test requirements and the test plan along with the production aircraft requirements, if you like. Just again, the bottom little paragraph there as well, just a pointer specifically. A lot of stuff I talked about above was kind of how we tackle things in industry, and I hope that applies and makes some sense for you guys in the UAS challenge. Just purely from our experience as judges, a handful of pointers for tests that you might want to look at in the UAS challenge. Ground handling is often left as an afterthought. Obviously, a lot of thought's put into how the aircraft performs in the air, but think about the surface that you're going to be landing and taking off from, and what that means for your landing gear arrangement. Gust performance is another one. Again, we've seen some beautifully designed aircraft that on a still day will fly excellently, but in the slightest gust of wind, we've seen aircraft flying into headwinds and practically hovering in the air instead of moving forward, and other ones being battered about the sky, and the autopilot's really fighting hard to keep up. So just think about what gust performance means to your aircraft and what that'll mean to the design. Repeatability and reliability of the airdrop in flight. Again, often see teams submitting really clever bench tests for their airdrop, and it works really, really well in the lab, and then they take it and fly it, and you get a hung payload, or the payload doesn't drop, or whatever. So have a think about in your flight testing campaign how you test that airdrop reliability, so that when you come to the competition, it's good to go. And the flight termination system. That's an interesting one, because that's something that's very difficult, if not impossible, to test in flight. Because of course there's a very, very strong risk that you'll lose the aircraft doing that. So how can you test that system in a way that satisfies yourselves and satisfies us that it's good to go in all the different circumstances in which the flight termination system might activate? So out of range, breach of the geofence, loss of signal. It's something to think about, just as how you demonstrate that to yourselves and us that that's safe, reliable. And then you want to add there, Steve?
Yeah, obviously there's probably quite a lot of testing you can do at a ground test level. All your systems and everything you can test before you go and fly. So it's important to do that. But one thing I want to emphasize, and it's probably historically not done very well by student teams in the challenge, is documenting all of this testing that you're doing in your report as well. Whenever it comes to the test and the manufacturing sections of the report, they tend to be quite light. And then whenever you talk to some of the teams, they say, oh, we did this, we did that, we did this. And you go, why do you not write it in your report? Do you know, so, you know, as Lambert already highlighted, Stephen and I are both judges, and we have been for several years. So we're speaking from experience here when we're giving you a bit of advice, and, you know, make sure you're documenting all of the testing that you're doing in your report, because it historically isn't something that's done very well. Even the smallest test that you're doing is still a test that's giving you the confidence that your aircraft's fit for purpose and will perform as you designed.
Next slide, please. So moving on then to the manufacturing assembly side of things, a couple of slides here, and it's really just some pointers as to things to think about. Again, we're hoping you're well through your design cycle anyway, and some of your assembly is going to be locked down by now. But just a few pointers. In terms of access, just make sure you've got appropriate access. Again, this is going to sound very, very simple, but we have seen cases in the past where designs have sort of failed to do this, and students are having to cut holes in the side of things or reach in with some very, very awkward tools. So structurally, make sure you've got sufficient access for fasteners and for interfacing structural parts. Again, I've seen wing designs before where you know, the wing size really nicely, and you've got spars exactly the right height and size and depth that they need to be, and then when they come to actually jointing that spar into the aircraft, the joint just isn't up to the job. So make sure all your analysis and your design work sort of carries through from the individual components to how they all come together, and that you're transferring those loads from the wing, from the tail, from the landing gear into the structure in an efficient manner, and that you've got the access when you're assembling the aircraft to reach in and do up those joints without any sort of you're not working blind effectively. Similarly for systems, I think this comes up in the following slide as well anyway, but I've seen a lot of cases in the past of very nicely structurally built aircraft, and then the systems are nearly thrown into them. The wires are kind of all over the place, they're not clipped neatly and all that. So consider how your system is being laid out, and particularly the system routing. You know, you'll have a battery here, you'll have servos there, you'll have your control system. How do you get the wires from one to the other? How do you do that in a neat fashion? If you've got an excess of wire, how are you stowing that so it's not getting tangled up and on the top of everything? That neat build is very, very important. It says to us immediately as you look at the aircraft, before we've ever spoken to a student or doing anything else, you can tell by eyeballing an aircraft a lot of the time kind of the quality of the work, and that tends in the teams that achieve really well. You'll see the teams that do well in the written reports and do well in the fly-offs also tend to have very well built, very neat aircraft. It'll also give the scrutineers a good first impression, and that does matter. and it'll help you as well. This isn't just about impressing us and scoring points. You know, when it comes to actually assembling the aircraft, when it comes to safety, neat quality work will make all that a lot easier, and a lot easier to demonstrate to us as well. In terms of repeatability, I've given away an example there on the right hand side of what we call a storyboard, and again, that might look dead simple, but this is a screenshot taken from a pack I produced years ago. This is the kind of thing we're doing in industry, and it's very, very simple. Big visual diagrams of how all the bits come together and in what order. The other term I've heard for these two is build cartoons. So don't be afraid of dumbing it down effectively. You know, we talk about checklists there. It doesn't have to be writing. Use big pictures, arrows, big labels, make it nice and simple and easy, and understand the correct order and the sub-assemblies that you're going to do as you bring the full aircraft together. If your aircraft's made up of 10 major components, there'll be all sorts of different ways and different orders in which you can assemble them, work out the most efficient ones. And then lay it out very simply for the rest of the team. Say anything else there, Stephen?
No, next there, I think we can add a bit more on the last slide. There's one more slide. Yeah,
there's one more. So quite specifically then when it comes to the time challenge, so there's a time segment where we will watch you assemble your aircraft kind of from unpacking it from the box to being ready to fly effectively. Don't rush that. Most teams, the approach we've seen in the past is just to panic and rush to it as fast as possible. Think about an F1 pit crew. So you watch them changing the wheels in the car, refuel, whatever it is, and it's dead slick, it's dead fast. It appears to be rushed, but it's not. Those crews have practiced and practiced and practiced. Everybody knows their job. Everybody knows what they need to do, when they need to do it. But most importantly, the car is designed for that kind of quick turnaround. Before ever there's a pit crew around the car, the designer has thought about how easy is he going to make this for that crew. So while the pit crews get a lot of praise, and rightly so, don't forget that the speed that you can do this at starts at the design stage. Do use checklists. That maybe sounds obvious, but a lot of teams don't. Do use checklists. Don't be afraid to make those diagrammatic. It doesn't have to be words. Make it nice and simple and easy and clear. Design parts that can only fit one way. Have seen teams try to put the left-hand wing on the right-hand side of the aircraft and not kind of panic and wonder why it's not good together. Make it, again, make it very simple. Again, robustness of joints, you're bringing big structural components together, but how are you transferring those loads through the joints when you're designing an aircraft that could be broken down? I've got a couple of pictures there on the right hand side. That's from a YouTube video that's worth going and looking up, of how a team put a General Atomics Reaper together. So that is very similar kind of in concept to some of the aircraft you guys will be developing, just scaled up and industrialized. But those wings come flat packed. You can just about see in the lower pictures the spars stick out the end of the wing, and they integrate inside the fuselage. Worth taking a look at that video. The kind of thing you guys are doing isn't just limited to competition or model scale flying. This is being done on an industrial scale. So the guys, General Atomics, that have designed and built the Reaper, have thought about all this and how to make that easy and efficient and robust. One more point there then at the bottom as well that we've seen teams trip over on in the past is when you're doing your mast estimates for the aircraft, include your consumables. It's not just the big structural components and the big systems components. There's going to be glue, tape, fasteners, wire, and all that sort of stuff, which often gets left out of those lists. As Lambert says, there is a weight limit for the competition of 10 kilos. And we've seen teams come fairly close to those, and then the actual aircraft is maybe just tipping over the edge, and oftentimes it's things like this that just weren't considered. In fact, going right back to testing, there's a very, very fundamental test. You do an analysis. How heavy do I think the aircraft's going to be? You do a test. You put it on scales, and that will inform you whether your analysis is good or what you need to go back. And you can do that at a subscale level. You don't need to wait till you've got a full aircraft. Weigh a wing, weigh a fuselage, weigh some components, and build that picture up and understand if the way that you're approaching the mass analytically is actually matching up to reality, and if not, why not? Anything else there, Stephen?
No, just one more thing to add on there for the actual challenge itself is it's not a bad idea to have a package of spares along with you. You all won't fly graciously and gracefully and land in one piece. Believe me, it's always good to have a box full of spare parts, or have a strategy for how you're going to repair your aircraft if and when it gets damaged. Being our tip to get quickly back out into the queue for the flight line.
All right, I think that's us.
That's all from us. Yeah.
Yes, thank you very much.
Lambert, I think you were going to go through just a quick overview of the awards.
Sorry, I'd forgotten about them. Yes, right. Just a reminder that there aren't just the sort of grand champion type awards that are made up of the scores from all the reports and the mission scores, but there are a whole host of other awards that are made at Buckminster. So there's plenty of opportunity to come away with something from this competition. So innovation, design, environmental safety, and the scrutineers put out some awards as well. And so, you know, it's well worthwhile looking at those as well. Lots of opportunities for coming away from something, and it gives some indication of the things that we'll be looking at as we go around. Also, don't forget the Dragon's Den presentation, which is quite important. You know, is your business plan, is, as I mentioned earlier, you know, aid agencies don't have huge amounts of money, so a cost-effective solution to delivering aid is really important. So you know, that's something you can tell us about in your Dragon's Den presentation. I think that's it on that. So I think it's back to you, Alice.
Yes, well, we've got our Q&A session now, so we will open microphones, and if you'd like to go ahead and ask a question, please do so now. In the meantime, we have got an unanswered question in the chat from Anna, that if they carry a pair of spare wings, do they have to be included in the box in which we transport the UAS wing as an example of a manufactured part? Does anyone have an answer for this one?
I wouldn't think that's a problem. I think we would prefer you to bring some spares, so that, because we want to see as much flying as possible, and therefore we wouldn't penalise you, if you like, in that respect. So I think sort of major spares like that can be brought separately.
Okay, thank you so much.
Do we have any more? There's a few more questions in the chat around will the presentation be shared to view later? Well, the recording will be uploaded to the IMechE YouTube channel, and we will share the presentation with permission from the authors. So there's a few more questions that have been answered around how will you fly the model for waypoints and other missions? Do we have to do something about this? And Will, you provided an answer for that, so that you don't have to do anything for that. So we will fly them around a representative mission, but it will not be the exact one you'll get at the fly-off. Couple more questions. What parameters are evaluated for the environmental awards? Does anyone have an answer for this one?
Well, I guess we're looking that you've taken serious consideration about the environment. So it's the materials you build the aircraft from, Anything else you can impress us on your approach to environmental issues? I mean, I talked earlier about the payload box, and so if you do need to put something around it to attach to your release mechanism, think about it being biodegradable or not damaging the environment. So using releasable, manually releasable tie wraps, for instance, is maybe not such a good idea because, lots of plastic tie wraps are polluting the world already. So adding a few more is not a good idea.
Thank you. There's another question. Due to our long journey and the school's need for accurate travel time, we need an invitation time that is longer than the competition. So in our invitation letters, for visas, we invite you for the competition dates, for the competition, and then we ask the embassy to take into account that of your travel requirements, that you will be arriving before and could be leaving after the competition dates. So this is our standard letter that we provide for all teams coming from overseas. And then there is another question around deadline for when the teams can make bookings for the campsite. I will have that date for you next week. Yes, I'll be asking the manager of the BMFA what those deadlines are, and so there'll be more information coming out next week. Do we have any other questions? Okay. So we've got a question around X-plane submission, specifically waypoints. Will the judges just fly manually, or do we need to add extra documents and explanations on how it can be automized using external apps like Mission Planner? That one.
We're planning on hand flying the aircraft. Yes, thanks, Christina.
Okay, thank you. Thanks, Christina. Is there any way to know if the invoice is correctly paid? Yeah, we can find out if your invoice has been paid. We will be getting an update from our accounts department tomorrow. Concerning the maximum costs of the components, do we have to consider the real price of the component or the price we paid? E.g., if we have a sponsor that gives us a component for a reduced price.
I guess you need to tell us what you paid for them, but I think we do ask you to acknowledge sponsorship in your design and development specification. And so I think it's in the summary at the beginning. We ask you to tell us about sponsors. So if you can tell us about what you're getting from your sponsor there, we will take that into consideration.
Great. We have another question on the payload, I think here. The package with parachute that we received has different dimensions than in the rule book. Which ones should we design the plane for?
Well, that's a good question. I think we did update the dimensions in the rules, so maybe you're working to the old one, because there has been some ambiguity on what's on the Dropbox website.
Can you put down what the dimensions you've got are, and we can have a look at that?
Yeah, it would be useful. I would suggest, if that's what you've been sent, is that you use that. But if we find that your dimensions are different to we have in the rules, we need to advise others of that, don't we, Will?
Yeah, if it's a case of there's variation in the boxes as built compared to their sort of nominal dimensions, and that'd be, yeah, we're going to need to take into account that. It's definitely the micro UAV drop box, and it's not one of the other scale, is it?
Yeah, I believe it is the micro UAV. Yeah, and we there's some questions around more than 10 students attending, and it does say in the rules that we are limited to no more than 10 members per team, plus your academic lead or team supervisor. Any larger number than that would have a knock-on effect with the logistics and insurance and amenities at the site. So Ben has picked up that the 2024 rules say that the package without parachute is 20 centimetres and theirs is 30 centimetres. Yeah.
Well, we clearly have to look into this. I'm just.
Lambert, I've just pasted into the text the section from the table where it provides the rules, and it says 30 centimeters, not 20. Have you
Yes,
definitely
I thought we'd updated it. Yes.
So is this something we need to take and look at?
It sounds like they might be using an old version of the rules.
So do we need to get clarification on these dimensions?
So it sounds like the dimensions that they've got are what we've got in the latest version of the rules. So to your specific question, are you going to design it to which dimensions should you design it to? Use the package that you've got, because it sounds like it is the right size package. So yeah, whatever you've got written down somewhere, the package you've got sounds like it is the right size. So design it to that package.
Thank you. Any more questions from anybody? Right. Yeah, Will's just said the diagram doesn't exist in the current rules there. Okay. I think if we don't have any further questions, then we would be ready to conclude this webinar. And if you do have any questions that arise afterwards, email us at the UAS Challenge inbox and we will be pleased to get back to you. Thank you very much.